Okay, today in the Smithbonics extremely small little electronics table here, we're going to be talking about batteries, which is the right battery for you to choose for your robot or electronics project, which one I've ultimately decided to use for my dream robot down the road. And this is all coming up next in this video, so stay tuned. Alkaline batteries is probably one of the most common batteries you can find anywhere. And that's one of its biggest pros. You can find these in supermarkets, you can find them in electronic stores, drug stores. They're everywhere, and you'll find them oftentimes in the impulse aisle. People realize, oh, I need a battery for that remote, or I need it for this or the toy or whatever. So that's one of the biggest pros of alkaline batteries. You can find them everywhere in all sorts of sizes, whether it be D, AA, or smaller AAA, 9-volt batteries, even a large lantern battery if you need it. So definitely available, and that's probably one of the biggest pros for them. Long shelf life is another one. They don't last forever, as you'll see in a moment, but pretty good long shelf life for those. They got a good high and low temperature performance as well, which is always a plus in anything that's going to be used remotely, as you need for batteries. One of the cons for alkaline batteries is they're disposable. So once the power is gone, they become useless, and you need to dispose of them responsibly, of course. But that's it. They're a one-time use battery, and that would be probably one of the biggest cons, especially if you're going to be having a project where you're going to be doing a lot of different things with your project or robot, and want to keep replacing batteries all the time. You want to be able to recharge them. So that's one of their cons. They don't work well in high drain devices, since the internal resistance is going to limit the output current flow. But if you're just doing a little small project, a lot of times for Arduinos, plug on one of these instead of hooking it up to all the wires, power supply. That way I can take it wherever I want, if I'm working on the couch or whatever. Or if I'm just taking it remotely, it's just a nice, quick, easy way to experiment and to test out things. So alkaline batteries definitely have their place, but not the one I chose for my ultimate project, but could be for yours, or like I said, just for general purpose use. This is an alkaline battery that has seen better days. This one was in an electronics device quite some time. As you can see, the bottom part is bulging out. Top part is all corroded. Alkaline batteries are notorious for leaking when they get kind of old. That's why sometimes if you have them in old devices you're probably not going to use, you probably want to just get rid of the batteries, take them out. Basically, this happens because hydrogen gases eventually start to leak out, and that leaves a trail of potassium peroxide corrosion that's going to form on the top. You're going to see that kind of crusty white stuff there. That's what that would be. I'm wearing gloves, kind of small gloves, because it's quite toxic, and it can cause skin and eye irritation, so you want to be careful with that. If you have them on your terminals, on this old device I had, as you can see, there's a little bit of corrosion on the negative terminal there, and I can clean that off with a little vinegar, so the acid will take that out, and then a little alcohol after that to clean it up, and it'll be as good as new. This battery, though, is toast. Lead acid batteries. This is a gel lead acid batteries. These do have some pros. Typically, these are used for higher power applications. There's two main types. There's the flooded lead acid battery, VRLAs. They have a liquid electrolyte in them. Those are the type you normally see in a lot of different cars, or at least some of the older cars particularly. and they'll have, the liquid in them, so they can't be turned up and side down and around, which is not normally something that a car is going to do unless you're extremely unfortunate. But there's also this type here, which is a sealed lead acid. It uses a gel type electrolyte. It doesn't have any memory effect like NiCad batteries. It has its purposes. I was actually thinking initially that maybe I could use this in the legs of the robot. I thought it might be a safer battery technology to use. But as I did more research and as I felt one of these, it just didn't seem practical. This is made out of lead, and lead is extremely heavy. So even though the legs would just be moving up a little bit each time, it just didn't seem very practical. And as I found out more about this kind of battery type, it really just didn't make any sense. And there are some safer alternatives that I could use for that. So being heavy is one of their biggest issues for the sealed gel types, kind of a poor energy density as well. Might be good for your project though. Sometimes they're using alarm units, various higher power applications where it's not going to move around a lot, and can just take a little trickle charge. They do prefer that more so than heavier charges. So yeah, that's lead acid battery for you. Nickel cadmium batteries. This is a very popular rechargeable battery. You can find them in many places, not as common as alkaline, but very easy to find, very popular for various consumer electronics that have the need to keep putting in batteries. They are relatively low cost as well. They have higher energy density than their sealed lead acid brothers battery. And essentially, they will cycle around 1,000 times, for these batteries. Some of the cons of them, they do suffer from what's called a memory effect. So if the battery goes down to a certain level and you pull it out and you recharge it again, it's going to kind of remember that level and think, oh, I should be charged to here instead of up here. So that is one of the effects that can essentially reduce the life of it and efficiency, because if it's only going to a certain voltage, when you wanted it to go all the way up here, you're not going to have as effective an experience with that. One of the other issues is that they are generally in these packages you'll see like AA and AAA, same packages you'll find in regular batteries, so it makes them easy to interchange with various devices. But their voltage is a little less. It's 1.2 volts generally for these. Whereas an alkaline battery of the same type, it's going to have 1.5 volts. So sometimes you need a little more. Sometimes it's not going to last as long. So that's one of its downsides. They do perform best when they're deeply cycled and don't perform very well when they're shallow cycled. So these definitely have a place. Many smaller robots, like kit robots and all that, they'll have something like this to utilize. It's just a convenient way you can get chargers for these. Oftentimes they sell the chargers with the batteries themselves. So they're very common and can be useful. I use them for camera equipment I have. Just make sure I just drain the battery completely and then recharge them and start all over again. So definitely have a place, but not with my particular robot project that I'm contemplating. So this just will not work for that. Might work for a project of yours though, so something to keep in mind. Lithium-ion batteries. These are very popular batteries. They're found in many devices that you probably are holding in your hands. They're found in this device that's recording this video right now. They have roughly twice the energy density of NiCad rechargeable batteries. They have none of that memory effect that NiCads do have. a relatively low self-discharge rate as well. Just when they're stored, they can be rapidly charged. And when they're charging, the batteries are relatively cool as well. So they have a great energy density, very popular battery type in all sorts of things from electric cars, although there's another variant that they're using more now. Cell phones, mini devices. Drones typically use these in a different package where they're smaller cells and just shrink wrapped. So you may actually see, if you see something in some sort of device that's shrink wrapped, it's likely going to be a lithium ion. Some of the cons is this is the highest cost rechargeable battery pretty much that you can get out there. So yeah, they're a little expensive. They also have to be protected against excessive discharging and overcharging. It's very dangerous if you don't do that. These are 650 batteries, 18 millimeters by 650 millimeters. Lithium ions can be dangerous if they're overly charged or overly discharged. So they normally will come with these small little electronic circuit when they're in packs or in your device. You need to design it with some sort of control mechanism to make sure that they're charged and discharged in a safe way. If you don't, these can explode. They can catch on fire. Very nice hot fire as well. So this has caused places to burn down and all that. So you want to treat that charging process with respect. You don't just plug it into a charger and expect that it's going to work as normal. So it has to be special charging for these. You have to make special allowances for that. It was one of the reasons when deciding on did I want to include these into my dream robot eventually. I decided against it. I was a little worried about the chemistry in these. The battery management part I didn't have a problem with. There's plenty of circuitry you can find and designs you can find to help with that. But that part made me a little nervous and a little hesitant to use these. Am I going to use them on other projects? Oh yeah, heck yeah. This is great. Like I said, the energy density is fantastic as long as you have a good charging circuitry there. They're fine to use on just standard projects. The problem with a robot, though, is a robot's going to walk around. It's going to be doing a lot of physical things. And if this gets punctured, you don't do it yourself. It's very dangerous. But if this gets punctured, you can see internet videos on YouTube of what happens, and it's not pretty. So definitely didn't think it was good for a robot because they can fall. Things are going to happen. They're in the physical world. So if they fall and something pierces this, then you have a fire in your very expensive built robot that would have taken you a long time is going to go up in flames, and it's going to become a danger to you and your household. So decided this particular chemistry, even the lithium polymer type, just wasn't right for me. So I'm not going to use those in my particular project, but they're very good for many different projects, and you may find a lot of good uses for those in whatever kind of package that you do find. As long as you have the right circuitry to keep it safe, make sure when you're charging those, you have a really good charger specific to this battery chemistry, then you should be okay. Which now brings me to the lithium iron phosphate, commonly referred to in internet searches as LiFePO4. For the iron content, essentially, iron phosphate. These are lithium cells still. Their voltage is a little bit less, 3.3 volts. This one's a 1,100 milliamp, 3.6 watt hours. So their energy density is a little less than you'd find on your standard lithium ion or lithium ion polymer batteries. But they're quite a bit more stable. They have pretty much the same properties. Again, a little bit less voltage. Your charge rate is going to be a little less. so far as the voltage that you're going to reach. Because of that, you don't want to overcharge these or over discharge these, just like other lithium batteries. But because it's lithium iron phosphate, the chemistry is more stable. So if you overcharge these, which you don't want to do, because it's still going to produce heat and gases and it's not safe. But if you overcharge these, they don't tend to explode. They tend to swell up and eventually start to, issue out some gas and stuff, which shouldn't be good for breathing. So you definitely don't want to do that. You still want to have circuitry on these. But the battery chemistry is a lot more stable. They don't generally catch on fire. They don't generally explode. They will get some discomfort and swell up and start to spew some stuff, but definitely much safer chemistry. A lot of these are now going to be used on many more cars. I figured if I have a robot and they're doing all sorts of stuff and they're interchanging with the physical world, they may fall. And if I have any sort of issue with these, this is a much safer alternative. So the lithium iron phosphate is the battery of choice for my dream robot. It might be a good choice for you too on your particular project. Again, the voltage is just a little bit less than you normally get out of these. You might have to plan for more, particularly if you're going for a higher voltage. So just a shade below, well, a little less than you'd find energy density wise from the lithium ion polymers. But the safety factor and the chemistry just makes them really attractive, particularly for my application. Might be good for your particular application too, depending on if that safety factor is good for you and if the reduced voltage will work for you as well. So that is going to be my choice for the dream robot. I'm actually thinking about having, of course, they're going to have their own circuitry, just like lithium ion in general, to make sure they don't overcharge or over discharge. So I'm still going to have that, and it's going to be multiple packs. I'm going to probably have these in multiple locations throughout the robot, all tied into the general power system, but that way I can distribute the weight. These are, again, 18650 packages, not much more than the regular lithium ion. But that's essentially the plan for the robot ahead. So, they come with little buttons. Sometimes this one's a flat head. But that's the battery of choice for my robot in the future. Might be the battery of choice for your particular project as well. So that is the one I'm going to choose. Well, that's our Smithbotic overview of battery technology and what might be right for your particular project. What are the pros and cons of each different type of standard battery type out there? As you can see, Bruce does need a new battery, so I'm going to have to work on that because he has stopped his clock. But hopefully you found this video helpful as we learn new things towards our ultimate dream project. We're going to be sharing them in these YouTube videos. So if you like what you saw, just hit subscribe. And we do thank you for watching, and take care.